RHS Pre-Calculus presents Hyperbolas for Dummies.
Many people have trouble with hyperbolas and their graphs. After seeing this video, you should be able to understand all the components of a hyperbola: the center, foci, asymptotes, and vertices.
The basic equation for a vertical hyperbola is negative x minus h squared over a squared plus y minus k squared over b squared equals 1, where hk is the center of the graph, a is the horizontal distance from the hyperbola's center, and b is the vertical distance. Another variable, c, not visible in the equation, can be found by the equation c squared equals a squared plus b squared, which represents the distance of the foci from the center of the hyperbola. The asymptotes are also important when graphing the hyperbola, and their slope can be found by using the equation plus or minus b over a. Asymptotes are important when graphing the hyperbola because they show the general shape. Vertices for a vertical hyperbola are h, k plus or minus b. They are similar to the vertex of a parabola and are the points that come closest to the center of the hyperbola. Given the equation negative x plus 1 squared over the square root of 3 squared plus y squared over 2 squared equals 1, the center of the hyperbola would be at hk, or negative 1, 0. To find a and b, you take the square root of the bottom of the equations, where a equals the square root of 3 and b equals 2. You can then use these two to find c with the equation c squared equals a squared plus b squared. After solving this, c comes out to equal approximately 2.6. Now, using all these things, you can find the foci and the vertices and the asymptotes. The vertices are at h, k plus or minus b, or negative 1, 0 plus or minus 2. The foci are at negative 1, 0 plus or minus 2.6, where c is 2.6. And the asymptotes are shown by plus or minus a over b, or plus or minus the square root of 3 over 2. We can now use all these points to graph. Here is the center at negative 1, 0. Here are the two vertices with the foci added, and the asymptote sketched in. You can now graph in the hyperbola. As you can see, the closest point to the center comes through the vertex.
For more practical applications, the hyperbola can be used to calculate how spacecraft use the slingshot effect to make a 180-degree turn on a celestial body without the need of reverse thrusters, and minimize fuel usage, as thrusters are limited in space without refueling stations.